Welcome to Florida State University's Department of Chemistry and Biochemistry Materials Characterization Lab, or what we like to call the MAC Lab. This is our SQUID magnetometer. SQUID stands for Superconducting Quantum Interference Device, which is used to study magnetic properties of materials with wide-ranging applications from physics to biology. The magnetometer can resolve magnetic moment changes as small as 10 to the -8th electromagnetic units over wide ranges of both temperature and applied magnetic field. All of these capabilities are fully automated for precise control and user-friendly operation. Our atomic force microscope, or AFM, is used to image materials and study their various properties on the nanometer scale. In addition to standard imaging, different modes of operation, AC, contact, lateral force, and phase imaging, enable users to perform scanning Kelvin probe microscopy, electric force microscopy, and magnetic force microscopy. The instrument has a dual view base for both opaque and transparent samples, and has a bioheater and a polymer heater accessory. Our inverted microscope is primarily used for observing biological specimens. Bright field differential interference contrast and epifluorescence microscopy are the observation methods available for this instrument. Our ultraviolet, visible, and near-IR spectrophotometer is used to study the absorbance of materials from spanning the electromagnetic spectrum, ultraviolet to near-infrared. This is a wavelength scanning double-beam instrument, and it uses a deuterium or tungsten halogen light source to span the ultraviolet, visible, and near-infrared spectral range. It has two detectors, a photomultiplier for ultraviolet and visible measurements, and a cooled lead sulfide detector for the near-infrared measurements. The instrument can be used to measure liquid, solid, and thin film samples. In addition to standard absorbance measurements, a universal reflectance accessory is available to enable high-precision, absolute reflectance measurements. The TGA 550 performs thermogravimetric analysis, which is a thermal weight change analysis measurement. The instrument is capable of high-resolution TGA, where the heating rate is controlled by the decomposition rate of the sample. Thermal decomposition of solid, liquid, and powder samples can be studied using this instrument. The attached quadrupole mass spectrometer can be used for evolved gas analysis simultaneously. In addition to the standalone TGA, the MAC Lab also has a combined DSC and TGA. This instrument is capable of simultaneously collecting both differential scanning calorimetry data, which indicate phase transitions, and thermogravimetric analysis data, which indicate the decomposition process. DSC and TGA are both used extensively in polymer chemistry. Our Fourier Transform Infrared Spectrometer, or FTIR, is equipped with different light sources and detectors that enable measurements from the visible to far infrared regions. The infrared spectra give structural insight to a sample. An attenuated total reflectance, or ATR, sample chamber consisting of a monolithic diamond crystal with anti-reflectance coating is used to characterize samples in many forms, including solids, powders, liquids, and pastes. In addition to ATR, the instrument also has transmittance, grazing angle reflection, and diffuse reflection accessories. The Fluoramax fluorofluorimeter can perform steady-state fluorescence spectral analysis with temperature control and time-correlated single-photon counting fluorescence lifetimes. LEDs with various excitation wavelengths are available for lifetime measurements. The instrument can measure liquid, solid, and thin film samples. The quantum yield spectrometer is a fluorimeter used for measuring photoluminescence absolute quantum yields. It consists of a xenon lamp light source, integrating sphere sample chamber, and CCD detector. Additionally, different color measurements like chromaticity, color temperature, and color rendering index can be performed. It can accommodate liquid, powder, solid, and thin film samples. The microscope-based Raman spectrograph is a fully confocal, high-resolution spectrometer that is well suited for a broad range of applications. The instrument is coupled to 3 excitation lasers, has 2 selectable gratings, and uses a charge-coupled device camera for detection. The true confocal microscope, along with motorized XYZ stage, offer high-resolution 2-dimensional and 3-dimensional Raman images. Accessories are available for various needs, including optics for polarized Raman spectroscopy and a setup to measure liquid or large samples in free space. The nanosecond transient absorption spectrometer, or TA, can measure ultra-fast electronic dynamics using the pump-probe model of spectroscopy. Laser-induced transient absorption and emission kinetics and spectra are observed using either a kinetic detector or a gated intensified charge-coupled device detector, and using time gates as short as 10 nanoseconds. Liquid and thin film samples can be investigated in this instrument. The femtosecond transient absorption spectrometer is used for spectral and kinetic investigations of photoexcitation events on the femtosecond timescale. The femtosecond TA operates similarly to the nanosecond TA, with the added benefit of shorter time gates achieved by its impressive internal optics.